Hey, my name is Ravi and this is Diksha Karnataka channel. I brought another topic for you, human eye and a colorful world. Well, CBSE exam is just a couple of months away and I'm sure your preparation would be going really well. And those who are still lagging behind, this session is going to be very good for you. Those people who have done really so far, they have prepared well. This it would be a good revision for you guys. All right. So my name is Ravi and I've been teaching physics for almost a decade now. I mostly teach the competitive level beyond 12th. And now I brought this topic for you, human eye and a colorful world. This is the third lecture. My initial two lectures have been on electricity. Please go and watch in our channel, Diksha Karnataka. Now, let's start the human eye and the colorful world. Let's start this topic. All right. So guys, this is an easy topic. This is quite easy topic. And question usually comes in this on short answer question, maybe a numerical or two, and some MCQs. This is where the question comes from. Very easy topic, very small topic. So we should be able to finish within 1 hour. So please be with me by the end of the hour, and you will be able to learn a lot from this. Okay, let's go. Let's start this. Okay, so this is what we are going to study in this entire chapter. Human eye and a colorful world. This is the chapter name. These are the topics we would be studying. One is your human eye. So this is first topic we will be studying. Okay, let me change the color. All right. So human eye. Second, we would be studying this topic. Eye diagram, power accommodation. This is a very important topic, guys. Power accommodation. Sometime on MCQs, you have questions from this. And defect of vision. Okay, I'm sure everybody knows and everybody has done this well. If you have not, please be with this. Be with me and I'll be able to tell you how to do this kind of channel. So this is a pretty good topic also. Then second, we will go through a refraction through a prism. That is the refraction of light through a triangular prism. Dispersion of white light by a glass prism. And recombination of spectrum of light. Then third topic we will be studying in this atmospheric refraction. Like why the stars twinkle. What is the reason behind that? Advanced sunrise and delayed sunlight. This is what we're going to be studying. And fourth one would be the scattering of light. That will be Tyndall effect and why the color of the sky is blue. So this is what we are going to cover in this topic. So just stay with me for an hour. We'll be solving some MCQs also together for the previous year questions which we have. All right. So this is the diagram of eye, guys. This is the diagram. So this, as you can see, please make a note of it, take a screenshot. I can be a little aside, take a screenshot of it so that you can understand what it is. So this is what, so in exam, usually they will ask you, okay, draw the diagram of eye and all this and name all these parts. So these are the parts of it: eye, cornea, iris, pupil, aqueous humor, crystalline lens, ciliary muscle, retina and optical nerve, vitreous humor. So these are the parts of eyes. Okay, and pupil, in this the important part is pupil. So pupil is something from where the light enters in the eye. Okay, so it is dark basically. Iris are the muscle which controls the pupil, the size of the pupil. So if there is too much light coming, our eyes pupil gets squeezed. This iris muscle, it makes sure that our eyes don't get damaged with too much of light. Now, as cornea, again this part, retina is where the image is formed, and this is the diagram of the eye. Please have a look. Ciliary muscle. Ciliary muscle is also very important muscles in our eye. What it does, it adjusts the size of the lens so that if you want to, let's say, we want to view the near object. So ciliary muscle will squeeze the lens. The lens will become a little bit fatter, and you can see the things which are near to you. If you want to see the object which are far off, the ciliary muscle will stretch the lens so that you can see the things which is far off. So ciliary muscle plays a vital role in viewing our objects. All right. So this is something it. I hope rest everybody. This is just a revision session. All right, and we're going ahead with this. So this is a human eye diagram. I hope this is pretty much clear. So next topic is power of accommodation. Okay, this is a very important topic for your CBSE board. So what is it exactly? So it is the ability of eye. It is ability of eye. Okay, say we have a lens in our eye. Okay, so eye is something this lens is naturally adjustable. It means the naturally eye has the ability, the body has the ability to adjust the focal length of the lens, and as the focal length is changed, the power of it also changes. Okay, so when the muscles are relaxed, lens become thin and focal length increases. You can see that. All right, so we can see the far objects. So there are ciliary muscles which controls the lens. As the ciliary muscle gets little relaxed, the focal length increases and we can see the far object. Okay, and the when muscle contract, the lens become thick and focal length decreases, and we are able to see the near object. Okay, for eye, farthest point is infinity, near point is 25 centimeter. Please make a note of this. One of the question can appear in your MCQ which says, okay, what is the farthest point for the eye? Your answer should be infinity. What is the near point? Near point is approximately 25 centimeter. All right, so let's go with next part. Next part is defect of vision. So defect of vision is, we have first defect is myopia. I hope everybody has learned this part, where person can see near object. It means the near object can be easily visible, but distant object can't be seen. Why it happens? It happens due to the elongation of eyeball. Okay, and this is the diagram which shows that. Okay, so if you for your exam, if the question comes, okay, what is myopia? So you have to write this definition. Please make a note of it. Write this definition and why it happens, and followed by with this diagram. It shows that what happens in myopic eye. Okay, see, this is far point of a myopic eye. Okay, this is a myopic eye where the image is formed before the retina. This is our retina. The image is formed before the retina, and we use this lens. Which lens it is? Please write me in the comment box. Let me know in the comment box which lens it is. All right, yes, this is concave lens. So this concave lens is used to correct the myopian vision. All right, so let's go ahead. Okay, I hope this is pretty much clear. Let's go ahead. The next topic is hypermetropia. So hypermetropia, what is it? What is it? So basically what we are able to, so what happens is we can see the far objects, but we cannot see the object which is near to us. All right, that is the problem. That is the thing over here. So this is called hypermetropia. So see, if you can see in this hypermetropia, as you can see, the image is formed behind the retina. This is important, guys. This is what you have to draw in your exam. Okay, so the image is formed behind the retina. This is called hypermetropia, and we use the convex lens to correct this hypermetropia. Right, this is pretty much okay, I hope it's pretty much clear to you. Okay, we can go ahead. Yeah, all right, keep on just liking the video. Okay, so next part is presbyopia. So this is, so we have three kinds of a thing which is given in your NCERT, which we have to study over here: myopia, hypermetropia. These are the three defects we need to study. So presbyopia is one of them. So what happens in presbyopia is that because of aging, as we age, let's say in mid 40s or maybe after 60s, okay, our ciliary muscles, they start to get weaker. So because our ciliary muscle starts to get weaker, our eye, they are not able to adjust the lens of the eye. So because of that, it is difficult to see the object. Sometimes myopia and hypermetropia happens together. It means that a person may have both hypermetropia and myopia at the same time. Okay, so it is usually corrected by bifocal length. Okay, so this happens because of the weakening of the ciliary muscles. Okay, but when this happens, so one is usually dominant the other. Let's say if hypermetropia or myopia happens, so myopia may be more in that case, or hypermetropia may be more. Anyways, you don't have to write that, so you just have to write this. What is presbyopia? The ciliary muscles gets weaker with age, and because of that we have this defect in the vision. It is corrected by bifocal lens. Okay, guys. Yeah, so what is bifocal length? It is a lens where there are two lenses are formed together. So the upper one is used to see the far off object, the lower one is used to see the near object. Okay, so this is how it works over here. We will discuss it further as we go further. We'll do some questions over that and we'll discuss this thing further. All right, so let's go ahead and see some more part of it. Okay, so next is your, okay, so that was the eye. So what are the things we covered in eye? We covered the defects of eye. hypermetropia, myopia, and presbyopia. Okay, we have covered the eye diagram, and what are the parts? It has about 9 parts which you have to label when the question comes. All right, and this the defect in vision. All right, so and the third one was power of accommodation. All right, now we are going towards the second part of this, that is the refraction of light through a prism. So what happens in prism, by the way? What is a prism anyways? So this is tetrahedral in nature, but we are only interested in the triangular part of it. So tetrahedrally, basically, if you see the prism in 3 dimension, it will look like this, okay, in 3 dimension. So, but we are only interested in the triangular part. This is called angle of the prism. A is called angle of the prism. So prism is made up of certain material which has certain refractive index. Okay, so what happens? There is one incidence ray. As you can see, this incidence ray which comes over here, this is a normal. So incidence ray outside is rarer medium. This is a rarer medium outside. This is a denser medium. So incidence ray bend towards the normal. So this is our normal, this is incidence ray bends towards the normal. This is the angle of refraction, and as the ray goes forward, again it goes away from the normal. This is called angle of emergence. So what is more important over here is, this is angle of incidence, this is angle of incidence, this is angle of emergence, this is angle of refraction, this is angle of prism. Okay, and what is most important part is, as you can see, if you take this emergent ray, you extend it from behind. Incidence ray, if you extend it, you can see this angle. This angle is called angle of deviation. It means this is our incidence ray. If the prism is not there, the incidence ray would have gone straight. But because of prism, it bends. If we extend this much it has bent. So if you see this prism, the bending takes place with like this. So this is our deviation angle. Okay, so this is the important part. So when you plot, this is good.
Red color use karna, yellow.
Right. Okay, so next part, next question. Okay, next is, all right, okay, recombination of spectrum. Okay, by the way, what happens in prism, by the way? Okay, so this is what happens. So prism causes dispersion of light. It means the light is divided into, okay, we have a white light, VIB, so it causes the dispersion of light. Okay, so dispersion of light, because of, so lights divides, white light divides into 7 parts of it. So red light has the least deviation, violet has the most deviation. Why? Because of wavelength. The more the wavelength, the less the deviation. Basically, the more the wavelength, and less the deviation. This is what you need to understand, guys. Okay, please make sure you write this. All right, so violet light has least wavelength, hence the deviation will be most. Okay, so let's go to the next part. This is called recombination of spectrum. What is a recombination of spectrum? We use 2 tetrahedral prisms together in this way. So when the white light goes, it divides into 7 parts. Okay, the most deviated one is violet, the least deviated one is red. All the lights will be between them, and then they recombine. Over here there is a screen where it is formed, so you just have to remember this, what is going on, that's all. This is all is required, nothing else is required. Okay guys, so let's go with the next part. The next part over here is, okay, all right, then rainbow. I hope you have come across with this, the rainbow. Question is, why does rainbow happen? Why does it occurs? Okay, it happens due to dispersion of light. Now what happens with dispersion of light? Same like prism, guys. Okay, prism also does the same thing. Similar thing happens with the water droplets. So whenever, let's say whenever it rains, so what happens is, if the rain particle, if the rain droplets are big enough, the gravity pulls them. But there are some rain drops which do not fall under gravity, they are suspended in the atmosphere. So those raindrop causes the dispersion of light and hence causes rainbow. Okay, let's see how it goes. Okay, so this is a rainbow, this is the drop. So when the light comes, it gets refracted and then strikes again, and when it comes out as 7 parts. That is VIB, GYOR. violet being most deviated and red being least deviated. Okay, and hence the rainbow is formed. Okay, all right. So next is our okay, 1 minute guys, let's go with next part. All right. Okay, so next question comes out to be refraction of atmosphere. So what happens with the atmosphere, guys? This is also a very important part. Again, this is just a synopsis, a revision class for us. All right. So what happens in atmosphere? We call it refraction of atmosphere. So one of the example is twinkling of star. Question is, why does star twinkle? If you see at night, how you see star gets twinkle continuously. What is the reason behind that? The reason behind that is Earth atmosphere. So Earth atmosphere has different layer because the density of the atmosphere, it becomes more and more denser as we go, as we come near to the Earth. So the refractive index of the atmosphere continuously changes. So when the light comes from star, it goes through multiple refractions and finally reaches to our eye. So this is how it looks. This is the star. Let's say this is a star. So the light comes on our eye, keep on refractive, and it reaches on our eye, as you can see over here. Okay, so this is the actual path, but this is where the star is appeared to be. This is called apparent position of the star. It means star is actually there, but because of refraction, it is visible over here at this point. Okay, okay, fine. So this is the apparent position. Now you will question, okay, sir, this is fine. The star apparent position is there, but why does it twinkle? What is the reason behind the twinkle? Guys, the twinkling is because of Earth rotation. So Earth keep on rotating, and because of as the Earth rotates, the atmosphere around it also rotates. So because as the atmosphere rotates, this star it just keeps on changing a little bit of it. It just keeps this apparent position of the star changes little bit here and there, and because of it, the intensity of the star becomes low and bright. Because of that, we see the twinkling of the star. As you can see, gradually changing refraction index of the atmosphere, intensity of the star increases, decreases, causes twinkling. Star seems to be higher in the sky. So where you see the star, you will see the star is little bit higher than the normal. This is what happens outside. Okay, so this is the reason of the twinkling of star. I hope it is absolutely clear to you. All right, let's go with the next part. Yes, please keep on commenting. Please let me know if you want me to explain something over there in depth. Please ask me that. All right. Okay. The next part is your delayed and advanced sunset. So same thing happens with the sunset part, guys. Okay. So what happens is, let's say this is our Earth. This is our Earth. Okay. So let's say the sun is over here. All right. So let's say this is the sun. So because of atmosphere, the ray of light keeps on bending and reaches to us, and if we extend it at the back, the sun appears over here. So actually this is the actual position. This is the actual position. This is the apparent position. So because actually what happens is, because of this, in reality the sun has already set. It's already gone below horizon. The sun already set. But because of this refraction through the atmosphere, sun apparent position seems to be up. There is about approximately 2 to 4 minutes delay. So we can see the sun 2 to 4 minutes longer than it is actually. So I would say, let's say in the evening the sun has already set, but we see 4 minutes more or 3 minutes more than that. Okay. Same thing happens in the morning. Before the sun rises, we are able to see the sun. Again, the difference is about 2 to 3 minutes. All right. So this is what happens in sunset. Okay. Yeah. If you like the video, kindly please keep on liking, keep on dropping the comments so that we can do more and more videos. All right. So let's go to the next topic. Next topic is scattering of light. So what happens in scattering of light? So okay, scattering of light happens is, wavelength mode scatter change in the direction of light due to the striking atom and molecule. So what happens is, guys, there are a lot of molecules in the atmosphere. So those molecules, what they do is, as the white light, that is VIBG, that is sunlight spectrum, VIBGYOR. So this white light has spectrum of 7 light. So as it comes over there as it strikes the droplets, as the water droplets, the dust particles, the molecules, there are so many things which are suspended in the air. So what happens is, because of that, it gets scattered. It gets scattered. So because of the scattering, what happens is, one of the reason, as you might have seen the sky is blue. Okay, why the sky is blue? Because a shorter wavelength gets more scattering. So blue is being a shorter wavelength, it scatters a lot, and because of that scattering, the sky appears to be blue. Okay, so this is what happens over there. This is because of the molecule, the light strike with the molecule and atom. Okay, next we have Tyndall effect. Okay, so what is a Tyndall effect? Tyndall effect is, you might have studied in the previous year, like 9th and all. So what happens is, if there is a, let's say there is a liquid in a container, and if you throw light on it, okay, if you throw light on it, so what happens is, here you can see the particles scattering the light. The particles scattering the light, that effect is called your Tyndall effect. Basically, it's nothing else. Okay, all right. So this is, I hope this is absolutely clear, guys. Okay, so far this has been our synopsis. I try to finish it as soon as possible. All right, because let's do some problems related to it, and let's go further. Okay, I hope this is absolutely clear to everybody. All right, okay, let's go next part. Okay, so let's do the multiple choice question. Let's see who does the answer. Okay, let's see. These are the past year problem, guys. These are the past year problems. So let's start the questions. So question number 1. So question number 1 is, when an object moves towards a convex lens, the size of the image. Okay, so question is that when the object moves towards a convex lens, so there is a convex lens. When an object moves towards the convex lens, what happens to the size of the image? Okay, please answer me in the comment box. Please answer me in the comment box, guys. Yes, please answer me in the comment box. When the object moves towards a convex lens, the size of the image, what happens to it? Yes, absolutely correct. All right, I can see few of you are answering it correct. So it increases. The size of the image increases. So as the object moves towards the convex lens, the size of the image increases. This is the answer. All right. Why? Because the magnification increases. Why? Because magnification, magnification increases, and because of this, the size of the image increases. All right. Okay, let's do the second part. Second question, I hope it is clear. Yeah, this question has come in past, by the way. Okay, this is one of the PYQs. All right, so let's do the next problem. So next problem is, all right, a man finds it difficult to read the odometer on the dashboard. Okay, I mean, a person is driving a car, there is an odometer on the dashboard. Okay, but it cannot see clearly a distant road, but at far he can't see. Okay, which of the following statement is correct about this man? Okay, all right. So this guy, the person who is driving the car, is not able to see the odometer clearly, but can see the distant object. So what happens over here? What is happening? The far point of his eye has come closer to him. What exactly has happened to him? What kind of defect this guy has? All right. The near point of his eyes has come closer to him. The far point of his eyes has receded away, or the near point of his eyes has receded away. What has actually happened? What has actually happened? So yeah, answer me in the comment box, please. All right, absolutely correct. I can see some of you have given the right answer, and the right answer is D. The near point of his eyes has receded away. So the near point has receded away. When the near point recedes away, what happens? He cannot see the object at near point, and he cannot read the odometer of the car. All right. Yes, absolutely correct. Okay. All right. Netra, absolutely correct. All right. So next part, next question. Let's see. Having two eyes facilitates in. What happens? Let's say we have both the eyes, right? God has given us two eyes, right? Everybody has two eyes. So what happens? So when we have two eyes, so what is the function of what they do together? The question is, Why do we have two eyes, and what is the advantage of having two eyes together? So the three things are given to you. It increases the field of view. It means we can see from right ahead to all the way left to right everywhere. It increases the field of view, which is yes, correct, yeah. Bringing three-dimensional view. Yes, we can see the things in the three dimension. Why? Because we have two eyes, right? Third is developing the concept of distance, size. Then, okay, developing the concept of distance, size. Then, what are these options? Which one is correct? Which one you think? A is correct, yes. B is correct. Is C correct? Question is C correct? Yes, absolutely correct. Yeah, I can see. Yeah, you guys are answering it well. Yes, keep on answering in the comment box, guys. Keep on answering in the comment box. Yes, the correct answer is over here. Is the correct answer is? Correct answer is yes, D, all three. So A, B, C. It means this is also correct, this is also correct, this is also correct. So the answer is A, B, and C, all three. Okay. All right. I hope it is absolutely clear to everybody. It's absolutely clear to everybody, right? Okay. All right. Let's do the next part. Okay. Next question. Yeah. Next question. Yes, absolutely, Netra. Netra, you're absolutely right. I can see, and a lot of you have given the right answer. Very good, guys. Keep on commenting the answers. Okay, now next question. Next question, please have a look. When white light enters a glass prism from air, the angle of deviation is maximum for, we have done this. Angle of deviation is maximum for what? Which light has the maximum deviation? Come on. Answer me in the comment box. We have spectrum V, I, B, G, Y, O, R. So as we go from left to right, the wavelength increases. This is a sign of wavelength, guys. Wavelength increases. Wavelength increases. And because of this wavelength increase, as the wavelength is more, the deviation is less. So if you go from V to R, so let's say I want to know, okay, which has more deviation, yellow or green? So green will have more deviation than yellow. Why? Because its wavelength is less. So whichever has less wavelength, deviation will be more. Whichever has more wavelength, deviation will be less. So in this case, you can see in our answer choice, see violet, yellow light, blue light, and red light. We can see violet. Violet has the lowest wavelength of the visible spectrum. Red has the highest wavelength in the visible spectrum. So where violet being lowest, the deviation will be maximum for this. I hope it is absolutely clear. This is a very important question for your board exam, guys. Very important question. Please make a note. This particular thing is very important. Yes, some of you are writing. Okay, very good, guys. Violet, some of you have given the right answer. But please make sure in an exam, they can even ask you, okay, which has more, blue or orange? Instead of giving this question, they can give you any other color. So you need to remember this, guys. V, I, B, G, Y, O, R. As you go from left to right, the wavelength increases and deviation decreases. All right, let's go. Let's take the next question. Okay, one cannot see through the fog because. Why you cannot see through the fog? What is the reason? A light suffers total reflection at drops. Fog absorbs light. Refractive index of the fog is very high. Or light is scattered by the droplet. What is the right answer, guys? What is the right answer? Please give me in the comment box. I'm sure, guys, your preparation would be going really well. And if not, you can please watch our videos. We have videos on various topics from physics, chemistry, maths, biology on our channel, right? All of us have really good content. Please watch our channel, watch our videos so that you can be updated. All right, we'll be keep on putting videos just before your board exams for the revision part. As of now, let's see this question. One cannot see through the fog because. What is the reason behind that? Okay, some people are answering. Okay, okay, so question, there are 4 answer choices. Light suffers total reflection at droplets. Fog absorbs light. Refractive index of the fog is very high. Light is scattered by droplets. So here the answer is, okay, have you seen, okay, at winters, you know, especially people who live in the North India, Nowadays, also in the morning time when you go out, you see there a lot of fog. You switch on the headlight. What happens? You see the light going all the way. You can actually see the beam of the light which is going, right? In normal way, you really can't see that very well. In fog, you can actually see that beam of light. So what is happening? Well, the light is being scattered by the droplet. In fog, what happens is the scattering of light takes place. Okay, so this is the reason the scattering of light takes place, so we cannot see through the fog. This is the reason light is scattered by the droplet. I hope this is absolutely clear. Yes, as those guys who have just started, you know, there are a lot of guys who just start just couple of months before the exam. It's fine, you still have time, still have a lot of time. Just keep on watching our videos, keep on doing the hard work, keep on doing PYQs, and that's how you prepare. Okay, come on, let's take the next question. Let's take the next question. The next question is, it's coming on your screen. Please have a read. Please read this question. So what does it say? In an experiment to trace the path of a ray of light through a glass prism for a different value of angle of incidence, a student found that the emergent ray. Now he's asking about, okay, if you read it, he's asking about what is the relation between incidence ray and emergence ray. What happens between them? So is emergent ray is perpendicular to incident ray? Yes or no? Is it parallel to the refractive ray? If you remember that prism, no, this was our prism. The light comes. This is normal. It bends and it further bends. So what is the right answer over here? This is our emergence ray. This is incidence ray. So if we extend this, this is the angle of deviation. So what is happening over here? Okay, so incidence ray, is it parallel to the incidence ray? Is it perpendicular? No. Parallel to refracted ray? No. Bends at angle or direction of the incidence ray? Yes. Oh yes. A lot of guys are writing the right answer, I can see. Okay, yeah. So it is bends at an angle to the direction of incidence ray. You can see this is incidence ray, right? It is bending. Incidence ray going like this, it is bending to it, as you can see. This bending takes place, right? I hope it is absolutely clear. Clear to everybody, right? Okay, so let's do the next question. Let's take the next question, shall we? Shall we go ahead? All right, let's go take the next question. All right. At the noon, sun appears white as. At noon, sun appears white. Why? What is the reason? Blue color is scattered the most, red color is scattered the most, light is least scattered, all the colors, white lights are scattered away. Okay, now this is the question. Let's see who answers one. All right. Yes? Okay. Please answer me in the comment box. Okay. Yes. Yes, I can see a lot of guys are writing the right answer. Yeah. Yeah, this is an important topic, guys. Okay, the question comes in exam. All right. Okay, so see what happens, guys, when the sun at noon time, the sun is right above us, right on top of us. That is a time, okay, the light is least scattered. Light is least scattered. Why? Because it is right above us. Remember, scattering of light happens because of refractive index. The light comes, bends toward the normal, from rarer medium to denser medium, bend towards the normal. But if the sun is right above us, it is exactly at the 90 degree. So the refraction cannot be more. It's the least refraction going on over there. So light is least scattered over there. This is the right answer over here. At the noon, sun appears white because the light is least scattered. I hope this is absolutely clear in this part. Yes? Yes? Yeah, it looks pretty fine, right? Okay, let's do the next question. Let's take the next question. Next question is, all right, let's see. Next question is, when light rays enter the eye, most of the refraction occurs at the, okay, where does the most of the refraction occurs? Okay, most of the refraction, okay, this is talking about the human eye. When the light rays enter the eye, so light rays are coming, entering the eye, where is the most refraction occurs? What happens? Where does it happens? All right, come on, answer me in the comment box. Answer me, everybody, come on, everybody, please. Answer me in the comment box. So, when the light rays enter the eye, most of the refraction occurs at the, is it iris? Iris is just muscle, okay, which controls the pupil. Outer surface of the cornea, pupil, or crystalline lens, where exactly it is? Yes? So the answer to the question, okay, in comment box I can say some people are writing the right answer, okay. So answer to this is outer surface of the cornea. Outer surface of the cornea. Please make a note of these questions, guys. These are very important questions. We have really handpicked this question for you guys, specially done, picked up, understood the concept. So I'm telling you guys, these are the very important questions which are being discussed over here. These topics are very important. It's easy topic. Just be with me. Let's do some more problems. I hope everybody is enjoying the class. Yeah, we're learning something new. I hope everybody is enjoying the class. Okay, let's do the next question. Next question is, okay, next question, which of the following statements is correct regarding the propagation of light of different colors of white light in air? Which of them is correct? Okay. All right. Red light moves fastest. Yellow light moves with the mean speed as that of the red and violet light. Blue light moves faster than the green light. All the colors of white light move in the same speed. Let's see who answers this. Come on, answer me in the comment box. Everybody, please answer me in the comment box. Okay. Please answer me in the comment box. So the answer of this is, yes, the answer of this is all the colors of the white light move in the same speed. See, you see, when, okay, the question is which of the following statement is correct regarding the propagation of light? You know, when the light moves, okay, in air, have you seen, you know, if lights are moving at a different speed, then you will be able to see the spectrum over there, right? Because let's say if red is moving faster, so you can see red more. No, it doesn't make any sense. So all the color of the white light move with the same speed, so that when we see the light, we see only the light. This only in case of dispersion through the your prism or water droplets. Dispersion, because of dispersion, they just deviate more. Otherwise, they move with the same speed. All right. So don't get confused with this question. The speed of the light is same over here for all the color. All right. Okay. So let's take the next question. Next question. Okay. Next question is, sky appears dark to passengers flying at very high altitude due to, have you ever flown in aircraft? I'm sure a lot of you have, right? So when you are flying in the aircraft, you can see when the aircraft is at really high altitude, then if you see outside, you see it appears darker. It doesn't appear any more blue. If you are at the ground, you can see blue, right? But if you are in the aircraft, you can see the sky is a little bit darker. Question is, why? At high altitude, it is darker. My question is, why it is darker at high altitude? Why? What is the reason behind that? So the reason is it lack of atmosphere? Is it inner surface of the water drop? Is it because of the vacuum outside? Is it because of the dispersion? Come on, answer me in the comment box. Yes, I can see some of you are answering. Yes, okay. So, Samuk Hegde, okay. All right, lot of you are answering. Okay, please keep on commenting. Let me see how many of you answered it correctly. Let me see. Come on, come on, come on. Keep on plotting. Come on, keep on giving the count. Yes, all right. No, vacuum is not the right answer. Yes, vacuum is there, but it is not because of vacuum. It is because of a lack of atmosphere. You see, atmosphere causes the scattering of light. And because of the scattering of light, we see the sky is blue. If the atmosphere is not there, the scattering is not possible. So yes, on top there is a vacuum, but that is not the reason. There is a vacuum, but that is not the reason. The reason is lack of atmosphere. All right, so don't get confused over here. Answer over here is lack of atmosphere. I can see a lot of you have given the right answer. Very good, guys. Keep on commenting. Keep on commenting. All right. Okay. So these were the MCQs. Okay, let's go further and hit some more questions. Assertion and reasoning questions. Let's do some assertion reasoning question. Okay, let's do. Let's go ahead. All right. So assertion says, question number 1. Assertion is blind spot is a small area of the retina which is insensitive to light where the optic nerves leaves the eye. Okay. There are no rods or cones present at the junction of optic nerve and retina in the eye. So what is the answer of it? Is assertion correct? Is reasoning correct? Or is reasoning is able to explain the assertion? What is it? Come on, give me a comment box. Answer in the comment box. Come on. See, the rods, number of rods, what does they decide? Yeah? Okay? Come on. So, blind spot is a small area of the retina which is insensitive to the light where the optic nerve leaves the eye. This statement is true. This statement is true. Okay? Yes, somebody is answering and your answer is absolutely correct. Okay? Okay, answer is Netra, your answer is correct. Hekde, your answer is correct. Very good, keep on commenting. And reason, there are no rods or cone present at the junction of optic nerve and retina. Yes, this is also true. Okay, so both are true. You know, in assertion and reasoning, even your answer, even this is right, still you can go wrong in this. So you have to be very, very careful in this particular type of question, guys. You have to be really very careful over here. You see, is reason is able to explain the assertion? That is the challenge over here. This is the kind of question where CBSE guy examiner wants to catch you. Assertion and reasoning question, you know, it really activates your critical thinking. So this is where your CBSE examiner actually wants to catch you. All right. So let's see how it goes. Both assertion. Okay, the question is, okay, assertion is true, reason is true, and as you can see, reason is able to explain the assertion. Right? At the end of the junction, there are no rods or cone present. It is a reason of because of that the blind spot happens, right? So in this case, both assertion and reason are correct, and the reason is the correct explanation of the assertion. You have to make sure, guys. Okay, if you see the B answer, assertion and reason are correct there also, but reason is not the correct explanation. So you have to see whether the assertion is correct, whether the reason is correct, or third question you need to see is whether the reason is able to explain the assertion or not. You have to use your common sense here. All right, guys. So answer over here is A. Let's go to the next question. Yes, thank you very much. Keep on liking it, please. If you like the video, keep on liking our videos, please. Right? Thank you very much, guys. Let's do the next problem. Assertion and reasoning. Okay. So next question is, the color of the pupil is black. Yes, the color of the pupil is black. Yes, everybody knows that. Okay, so this is true. Absolutely correct. The pupil is black as no light is reflected in it. Is it the right answer? Obviously, there is something, if something is black, this clearly means that the light is not reflected in it, right? Right. So this is also true. So now third question is reason is able to explain the assertion or not? Yes, give me, okay, tell me in the comment box, guys, please. Tell me in the comment box. Is reason able to explain the assertion? The answer is yes. Absolutely correct. Yes, the reason is able to explain the assertion over here. The pupil is black as there is no light is reflected in it, and because of that pupil is black. Simple actually. So your answer over here is A. Both the assertion and reason are correct, and the reason is the correct explanation of the assertion. Yes, not B, guys. This is answer is right answer is A. Okay, that's why you know that's why assertion and reasoning questions are quite tricky in nature. Okay, even though your assertion is right, even though your reason is right, still the third challenge over here is reason able to explain the assertion? Right? So please make sure you guys do it correctly. Think about it. Think 10 times before answering this kind of question, guys. Okay? Right? Don't do hurry. Don't go in hurry. Take your time, relax, understand it, imagine it, what's going on, and then answer. Okay, let's go with the next problem. So next problem is again assertion reasoning problem. Light from a distant object arriving at the eye lens may get converged to a point in front of the retina. Okay. The eye is producing too much divergence in the incident beam. Now, is assertion correct? Question is that, is assertion correct? Yeah? Is the assertion correct? Okay, it says light from a distant object. It means the light is coming from a distant object, far off, arriving at the eye, may get converged to a point in front of the retina. Okay, so what happens in this case? If the light is coming from far off, is coming and it is converging ahead of the retina. It means this is our retina. Light is coming from far off and it is converging before the retina. As you can see, this is retina. So what kind of defective it is? This is myopia, right? This is myopia, as you can see. So this is myopia, yes, absolute. Okay, this is myopia defect. All right, so this is true, yes, yes. This is myopia defect. Now, second, the eye is producing too much divergence in the incident. Is the eye producing divergence or convergence over here? Just see, is the eye is producing divergence? Converging means light is converging. Diverging means light rays are going away. It is causing convergence or divergence. In this question, as you see, the light is converging, but reason says too much divergence. So reason is false in this. As you can see, the reason is false. The light over here converges, but reason says it diverges. So this is false. So which answer is correct? Assertion is true, but the reason is false. Assertion is true, but the reason is false. This is the right answer. Yes? Okay? All right? Yes, absolutely it converges. Netra, your answer is absolutely right. It converges. But the reason says is divergence. So this is false, right? Your answer is right. It converges. But here if you see, the question says the eye is producing too much divergence. It's producing convergence actually. So reason is false over here. Alright. So correct answer is C. Assertion is true, but the reason is false. Alright. Let's do the next question. Let's do the next question, guys. Yes? Alright. Yeah, please like the video if you like the content part. If you're answering well, if you're able to understand well, please like the video. Alright. Let's go ahead and let's take the next question. And now the next question is, eye lens has the ability to focus clearly on the retina by adjusting its focal length. Okay, all right. So eye lens, the lens in our eye has the ability to focus clearly on the retina by adjusting its focal length. Yes, there are ciliary muscles out there which adjust the focal length of it, and we are able to adjust the focus, and because of that we can adjust the light coming in, right? So this is true, absolutely true. This is known as power accommodation. Is this power accommodation? Question is this power accommodation? Yeah, is this power accommodation? Yes, this is power accommodation. So is reason is able to explain the assertion? What is power accommodation? Power accommodation is eye can, okay, there are ciliary muscle in eye, so it adjusts the focal length of the eye so that we can adjust our eye as we see the image. Let's say you want to see the far off image, your ciliary muscle, it just relaxes your eye and you can see the far off image. If you want to see something near, your ciliary muscle contracts the eye and you can see the things which are near to you. So yes, and that phenomena, that thing is called power of accommodation. So yes, reason is assertion is correct, reason is correct, and reason is able to explain the assertion over here, and hence for that, because of that, answer A is correct. Yes, absolutely. I can see the comment box. Lot of options. Lot of guys are. Yes, option A is correct. Absolutely. Alok Yadav. Yes, you're absolutely right. Okay. All right. So Meg, okay. With I will. Yes, had there been convergence, the answer would have been different. Yes. Okay. Anyways, we are moving forward. Please leave your comment in the comment box, and all your question I'll be answering that after this. After the class, I'll be answering all your questions. Please leave your doubts over there. I'll be answering everything. All right. Okay. Let's go ahead and do more questions. One more assertion question. Let's take it. Let's take one more assertion question. Okay. The question says, assertion: a person suffering from myopia cannot see distant object clearly. Is it true or false? Come on, answer me in the comment box. Everybody. A person suffering from myopia cannot see the distant object clearly. Is it true or false? Yes? True, right? Yeah. So this is true. Okay. This is true. And this is due to eyeball being too short. In myopia, eyeball being short or long. What happens? What happens in case of myopia? In case of myopia, eyeball is elongated. Here is saying too short. So reason is clearly false. See, these kind of question you will come across, assertion and reasoning. Okay, just have to remember what is what. That's it. Pretty simple. It's not that difficult, guys. All right, just 3-4 lines and your chapter is done. Okay. So now, which is the right answer? Come on, everyone. Which is the right answer? Okay. Yes, long. Yes, Netra, it is long. Absolutely correct. All right. So, which is the right answer over here, guys? Okay. Yes, absolutely correct. The right answer over here is C. Assertion is true, but the reason is false. Right. This is where you have to be very careful when you are answering assertion and reasoning question. Even though you are right in assertion, even though you are right in reason, sometimes it happens that you miss whether the reason is able to explain the assertion or not. Sometimes it happens. Like see, A or B, all right? So you got to be really careful when you are answering assertion and reasoning question. All right, guys? I hope it is absolutely clear. I hope it is absolutely clear. Okay. Now, guys, let's do one more thing. Okay. All right. Let's do some questions. Some short answer questions. Let's take some short answer questions. All right. Okay. All right. Okay. We can answer this. Let's take this one numerical part, guys. Okay. Let's take one numerical. A person needs a lens of power plus 3D for correcting his near vision and minus 3D for correcting his distant vision. Calculate the focal length of the lenses required to correct this defect. Come on. You need to understand, guys, this is a very important question, which power of lens. Relationship between power of lens and focal length. This numerical comes in exam. Please make sure that you answer it well. So what is it? The formula is power of lens is equal to 1 by focal length. But remember, focal length has to be in meters. Please, I know so many guys, the focal length is given to in centimeter, you forget to change it to meter and you get it wrong. Please do not make this mistake. Please do not make this mistake. Okay. So power is equal to 1 by focal length. Focal length has to be in meter. But here the power is given to you. Power says, so power is plus, so case number 1 is power given to you is plus 3D. So focal length will be equal to 1 by 3 plus this comes out to be 0.33 meters. Correct? Second, it says power is equal to minus 3D. So your focal length is going to be minus 1 by 3 meters. that comes out to be minus 0.33 meters, right? Okay, fine. So this is the focal length in both the cases. First case, focal length is plus 0.33. Second case, focal length is minus 0.33. Can you tell me what kind of lenses it is? First one, focal length is positive of what lens? Can you tell me? Or power is positive for what kind of lens? Yes, in your comment box, please. So power is positive, or focal length is positive for converging lens. So lens which converges, that is a convex lens. So for a convex lens, the power is, okay, I'm just putting this. All right, for converging lens, that is convex lens, the power is positive. For diverging, power is negative. Okay, which lens is this? Concave lens. Please remember this, guys. This is a very important thing. This comes in exam. Okay, what does it say? Please have a look over there. A person needs to lens, okay, plus 3 power minus 3. This is given to us. We need to find the focal length. So if we have found the focal length. Focal length is 0.33 meters, and for the second one, the focal length is minus 0.33 meters. So focal length is positive for converging lens, which is a convex lens. Focal length is minus for diverging lens, which is a concave lens. All right. Okay. Yes, absolutely correct. I can see a lot of people have given the right answer on the comment box. Yes, guys, very good, guys. I hope you liked. I hope this video is quite useful for you guys. Okay, this question is very important. Again, the power of lens is very important. Okay, power of lens is very important. Sometimes the question comes, focal length is 20 centimeter. Find the power of lens. So here, please remember, first you have to convert into meters. That is 0.2 meters. Now I can say power is equal to 1 by 0.2. That comes out to be 5 diopter. This is what you have to understand, guys. This is what you have to take. It's very important. All right. Okay. Very important. All right. Let's do the next problem. All right. Okay. Let's see this. Okay. A person may suffer from both myopia and hypermetropia. What is the condition called? We just have 3 of it: myopia, hypermetropia, and presbyopia, right? Presbyopia. So presbyopia is a condition where he can have both myopia and hypermetropia. So this condition is called presbyopia. When does it happen? When it happens? When this presbyopia happens? This happens because of aging. As you age more, your ciliary muscle in your eye, it becomes weaker and weaker, and because of that it cannot adjust the lens as required, and we have these conditions as myopia and hypermetropia. Sometimes myopia is much more than hypermetropia, sometimes hypermetropia is much more than myopia, but the entire thing is called presbyopia. Okay, I hope it is absolutely clear, guys. Yeah, I hope it's absolutely clear. All right. Okay. All right. Okay, guys, so I hope you liked the video so far. Whatever has been going on over here, we have discussed so many problems, synopsis. If you just read those synopses, if you just do some problems, your lot of things have covered over here. So please like the video, please leave your comment, and please tell me if I have to take another chapter. As of now, I'm planning to take your next chapter pretty soon. We are coming with next chapter, that will be magnetic effect of current. We are planning that, and for your love and support, we can surely go ahead and do a lot of things over here. We are here to help. Kindly leave your comment in the comment box. Diksha Learning. Thank you very much. My name is Ravi. I'm taking a sign off now. Bye bye. Take care. All right. Thank you very much, guys. Thank you very much for all the comment. Thank you. See you again. Bye bye.